Hello. All right, today we're going to talk about conditional probability. The symbol P of A given B represents the probability that A will occur given B. Recognize that whichever variable comes second, that is your given. Okay? So your formula is going to be the probability of A given B is equal to the probability of A and B. So your and divided by the probability of B, which is your given. So recognize that whatever comes second again, that's your given. Okay? For example, we have the probability of A given B. Given that the probability of A is 0.3, the probability of B is 0.4, and the probability of A and B is 0.25. So in this case, we're going to have the and, 0.25, divided by the given, 0.4, which is going to give us 0.625. Again, and over the given. So for the next example, we got suppose that the probability of A is 0.35, B is 0.4, and the and is 0.2. So if we were to do the Venn diagram, we're going to make the probability of A, we're going to make that blue, and we'll make the probability of B, we'll make that green. Move some stuff around. So with the and being 0.2, we'll put that in the middle. So that with A being 0.35, that makes only A 0.15. With B being 0.4, that's also going to be 0.2, which is going to make not A and not B 0.35. I'm sorry, 45. Because that adds up to 0.55. So are A and B mutually exclusive? No. We know because the probability of A and B is not 0. What's the probability of A or B? So we're going to use our addition rule. So 0.35 plus 0.4 minus 0.2 equals 0.75, so 55. So if I add all three of those up, that's what we're going to get as well. So for our conditional probability, the probability of A and B was 0.2 divided by the given, which is B again, 0.4. And I'm getting that because that's the probability of B. add those. And it's 0.5. So are they independent? Remember, anytime you have a question of independence, you're going to multiply. So if you take the probability of A times the probability of B and multiply them together, so 0.35 times 0.4, that's going to equal 0.14, which is not equal to the probability of A and B for this problem. .14 is not equal to 0.2. So no, they're not independent. Okay, remember, you can always pause and rewatch if you did not understand something. Let's go to our next example. So we have this table here. 500 individuals were classified in 3 groups. So it's by age and by blood pressure. Notice the total is out of 500. And this is a great example of why we're not going to reduce, because we're going to be dealing with really large numbers. So the probability that they're in age group 3 is 150 out of 500. The probability that the blood pressure is greater than 90 equals 170 over 500. The probability of being in group 1 and the blood pressure is below 70. So group 1 and below 70 is 20 out of 500. So the probability of being in group 1 or blood pressure greater than 90. So group 1 is 100, and this is all out of 500, but for right now, I'm just going to use the value. So we got 100 plus being above 90 is 170. We'll subtract group 1 and above 90, so minus 20. So it's going to end up being 250 out of 500. So now given, and the cool part of when we have a table and we have a given, it makes it a little easier for us. So the probability is group 2 given that the blood pressure is below 70. So the and, group 2 and below 70 is 30 out of 500. So that's going to be divided by being below 70, which is 100. I'm sorry, below 70 is 70 out of 500. So when you have fractions, remember we got to multiply by the reciprocal. So we're going to do 30 over 500 times 500 over 70. They cross, and that's 30 over 70. So if we go look at our table, because with the given being below 70, so if we only look at this row, only at this row, our total is 70, right? And group 2 is 30. So our answer is still, if we only were to use the total for that row being 70, group 2 is 30. There's our answer, 30 out of 70. So if you have a table and you have a given, you can only look at that row or column. So for F, the probability that the blood pressure is between 70 and 90, given that they're in group 3. So with the given being group 3, I'm only going to look at this column. So my total is not going to be 500, it's going to be 150. And I want the blood pressure between 70 and 90. For that group, it's 60. So my answer is going to be 60 over 150. So if we used the formula of the and divided by the given, the and for between 70 and group 3 is 60 over 500 divided by the given, which is being in group 3, which is 150 over 500. Well, so again, when you're dividing fractions, you got to multiply by the reciprocal. So it's 60 over 500 times 500 over 150. They're going to cross. So my answer is still going to end up being 60 over 150. So either way, again, if you have a table, it makes it a little bit easier. All right, another example. We have 60% at a high-tech, of the applicants at a high-tech firm have a college degree. So we're going to say CD. And we're going to say that it's 0.6. 40% have at least 3 years of experience. So we're going to say E is 0.4. And 35% have both. So I'm just taking what's given in the problem. Okay, so if an applicant is randomly chosen, we want the probability that they have a college degree or at least the 3 years of experience. So in order to find the or, we need to find the individual probabilities, correct? So since we're looking for or, we're actually going to use the addition rule. So having the college degree, 0.6, plus having the experience, 0.4, minus having both, 0.35. So our answer is 0.65. That's your probability of having a degree or experience. Alright, again, if you have any questions, rewatch the video or make sure you ask me during our session. Thanks.